All right, y'all. So if you've had a little bit of trouble with this, I'm going to work through just a couple. So all we're doing here is finding the antiderivative of sine t, which is negative cos t, all right, from 0 to x. And then I'm substituting in, so I have negative cos x minus negative cos 0, which is negative cos x plus 1. So now if I take this and I set it equal to, down here, now I'm going to have this is equal to negative cos x plus 1, right? Because that's the integral from 0 to x of sine t dt. So the derivative with respect to x then of negative cos x plus 1 is going to be, well, the derivative of cosine is negative sine, so the negatives cancel, so I get sine x, and the derivative of 1 is 0. So I get sine x. Now if I repeat this, all right, I'm going to get something very similar. So you should be able to find a pattern. So for example, here, go ahead, pause, work through B and C for both of these, and then come back to check your work. So for this one, we should be getting negative cos x plus cos 3. For this one, we should be getting negative cos x plus cos a. And then if we're finding the derivative of each of these down here, then, well, what I want you to think about is that the derivative of negative cos x is sine x, well, positive sine x, right? And cosine of 3 is a constant, and the derivative of a constant is 0. So the derivative is still sine x. And then same thing for C, the derivative of negative cos x is sine x, and the derivative of cosine of A, where A is a constant, cosine of A is a constant, so we get plus 0. So notice how, what is the pattern that you see now if I were to write out the derivative with respect to x of the integral from 0 to x sine t dt? Well, you already found that that's equal to sine x when we put together A and B. So I want you in 3A to tell me what kind of pattern do you see?